Okay, so we have with us today Professor Sarah Rottenberg, who's a professor of product design at University of Pennsylvania, and asked her here to give us sort of a 20-30 minute crash course in the product design process, focusing on how the product design process that we are going to need to do for this first innovation challenge differs from the engineering design process that we're used to with FIRST Robotics competition. So we will take, again, 20-30 minutes for that crash course. And then she's going to help us look through our big brainstorm list and start to figure out what our next steps are with that challenge. So thank you so much for joining us. I'll let you take it away.
Great. I'm super excited to be here, and it's nice to see some faces of kids that I know who are not even my children. So thanks, guys, for showing up on a holiday to talk. So as Mr. Johnson said, I'm going to talk a little bit about what I teach in the program and the design process, mostly giving you guys an example of what that looks like through a project. And then talk about like maybe some tips or tricks that you guys can use in your projects. So first of all, the program that I lead is called Integrated Product Design. And the main thing that we teach is a process called human-centered design, which you might have heard of as design thinking. It's really about bringing, okay, so this is the Integrated Product Design Master's Program. You should all apply when you're ready. It's really about bringing these three lenses to product design. It's about design, engineering, and business. And when we talk about this, we think about bringing from a design perspective, how do we make things that are desirable for people? How do we figure out what matters and is meaningful to people? And then how do we deliver it to them in a way that they can successfully engage with it and interact with the things that we're making? From an engineering perspective, we think about feasibility. How can we bring in new technologies and make sure that we're able to deliver the technologies that we want to deliver through our products? And then from a business perspective, it's really about viability. It's about how do you set up a point of view that creates a product or a service or a business for people that costs less to make than people are willing to pay for it. And that can be a sustainable business in the long term. And so our students take classes in this human-centered design process that I'm going to be talking about. And then they also take other classes in design, engineering, and business to kind of round out their picture of everything that it needs to take to create new products. And I think it's really cool that you guys are doing this innovation challenge. I know it's partially because of this COVID situation and not everyone has access to all of their spaces and the things that they need to make robots. But I work with a lot of engineers who find that really thinking about innovation from more perspectives than just an engineering perspectives makes them better engineers, because it causes them to think in broader ways about the problems that they're trying to solve and how they can deliver technologies in a way that can really like make impact and make a difference in people's lives. So another way of thinking about this, just for a second, is we're trying to get viability from a business perspective, desirability from a design perspective, and feasibility from an engineering perspective, and get these three lenses to work together. And the place where we start is desirability. And that's because we have a belief that if we can figure out what matters to people, we can figure out how to make it feasible and viable. But you can build the coolest technology in the world, and if nobody cares about it, you're never actually going to have an impact on people's lives or make a difference in the world. So we use these processes to do two things. One is to define new opportunities, to invent things that are entirely new to the world, like the original light bulb. And the other one is to improve existing offerings. So to take things that work and make them work better for people. And our students do both. And the process that we use, there's a lot of different ways of describing the design process, but I like this one. It's called the double diamond model. And there's a couple of things I like about it. First, it talks about you start with a problem, and then you do some process to redefine the problem. And I think this is the thing that is maybe most different from how you guys are traditionally working in robotics. You're spending as much time understanding the problem and redefining the problem as you are generating the solution. So if you compare that to an engineering process that you might use, you start with asking, researching, and imagining. That's kind of understanding the problem, but all of the rest of it is that second half of the diamond. And I would say we tend to equally emphasize the first half and the second half of the diamond. In each phase, we're doing different activities. So at the beginning, we get a problem, or we come up with a problem on our own, and we spend a lot of time figuring out, what does that really mean? Who are the people involved? What matters to them? What's important to them? What do they care about? What current products or services are they using? And the way that this diagram is modeled, like with the triangle opening up, this is about diverging and coming up with as much information as possible. And then, though, in order to really define the problem, you have to converge again. You have to bring things back together to define the area of focus. And we do this by spending a lot of time kind of analyzing the research data that we gather to understand what's really going on and what's really meaningful and important to people. And then we have a redefined problem. And it's at that point that we start with the idea generation. And again, the goal is to develop as many possible solutions as possible. So we're diverging again. The research shows actually that the more ideas you have, the better ideas you will have. So the goal in this develop phase is to have as many ideas as possible. But as you guys know already, you have a lot of ideas. You can't move forward with all of them. So then the next phase is figuring out which are the best ideas. And then how do you develop and prototype and iterate those so that you come up with the best solution possible. So those are kind of the two halves of the process, one focusing on problem definition and the other focusing on problem solution. But just to add a little more complexity, the design process is really messy. There's this famous drawing that I'm showing you right now called the Design Squiggle. And anytime you see, a circle diagram or a process that is a straight line, be suspicious of it, because usually it's a lot messier in real life than it is in that model. And so I love this squiggle because it's true. And it also shows how, you're doing a lot of work up front, some of which you're going to end up throwing away because it's not important. And you're also not always moving forward. You're sometimes moving forward and you're sometimes moving backwards as you go from research and synthesis to developing your concept and prototype and then into the design phase. So it starts really messy. It's uncertain. It's unclear. There's a lot of noise. You're trying to figure out what are the patterns and what are the insights. And as you move through the process, you get to more clarity of what you're doing, and it becomes less messy along the way. So one thing I think that's helpful for you guys to think about right now where you are is circling back and forth between how are we defining what we're focusing on, and then how are we generating ideas? Because oftentimes the ideas you generate help you redefine what is the problem that you're really trying to solve. And new problems come up continuously. You understand more about people's needs and kind of refine your understanding about the problem as you're generating ideas. So I'm going to talk about a student project, and kind of show you how they move through the design process as part of that project. But before I jump into that, any questions about the process in general? You can ask me in the chat or unmute. Okay, I'll jump in. Okay, so this is a project called SWIV, and the outcome is a better toothbrush for all abilities. This is a team that started looking at how they could design products. So in the discover insight to the problem that they came into the project with was, how can we help kids with cognitive disabilities have better oral hygiene? And oral hygiene is about everything around brushing your teeth and flossing and taking care of your teeth. One of the students on this team, her brother has Fragile X syndrome. And there's a number of conditions that people have that cause simple activities that might otherwise be simple to be challenging for some people to execute. And the reason that oral hygiene is important, I know you guys all are told all the time to brush your teeth by your parents. It's important because you want your breath to smell good. It's important because you want to take care of your teeth and your gums, but it's also important because it has other implications for your health. So heart conditions can be associated with gum disease and things like that. And so parents of children with cognitive disabilities are very focused on how they can help their kids improve their oral hygiene for health reasons, and also because they want their kids to be able to function independently. And toothbrushing is one of those signs of independent function. So the team started by talking to people. And you can see in this picture, they talk to all different kinds of people. They talk to kids, they talk to parents, they talk to dentists, they talk to social workers, they talk to schools, they talk to grandparents, just to understand what is going on in this area and how can we learn from people what matters to them. The other thing they did, which is I think something that you guys are doing now, is they looked at what are the existing solutions that people are already using in this space. So chances are any topic that you focus on, people already either are buying products or services or have created their own things to help them meet their needs. And those can be really great ways to learn about the problem. So in this case, they saw people were using visual schedules, they were adapting toothbrushes on their own, and they were using all kinds of special timers. And you can look at what are existing solutions and start to say, okay, how can I look at this to help me understand more about the problem? So for example, the tennis ball on the toothbrush, obviously that's something about being able to hold onto the toothbrush better. And the tennis ball does a really good job of that, but it also falls down on some other criteria that might make a good solution. So for example, you can imagine it gets really messy and really dirty easily, and it's probably very hard to clean toothpaste off of your tennis ball. So oftentimes existing solutions will help with a part of the problem, but not necessarily help with another part of the problem. But this is all research to kind of understand what's going on and what matters to people. So after they did this, talking to people and looking at existing solutions, the team focused on defining what is the real problem that we think we can solve. And what they came up with was this triangle of criteria. So they saw that there's a couple of reasons that make it challenging for kids to brush their teeth. One is motor function. So it might actually be hard to grip the toothbrush and to turn your hand in the way that you need to in order to brush your teeth. The second is attention, and that's two pieces. One is, can I get somebody to brush their teeth for 2 minutes? I don't know, I'm the parent of teenagers. I can't get them to brush their teeth for 2 minutes twice a day, every day. But also, can I focus on the task for long enough that I do a good job, right? So that I'm doing the bottom and the top and the sides and both sides. And then the third piece is learning, which is how can I help kids learn how to brush their teeth? So if you remember, the visual guide was really a step-by-step process to reinforce how to do it. And so this team ended up defining the problem in that a good solution helps address motor function challenges, attention challenges, and provides a solution that's easier to learn. So then they know what the goal is. And then the next step is to come up with as many ideas as possible for how to address that goal. So in this case, the team did a couple of things. First, they went back out to kids and parents and dentists and social workers and had them come up with their own ideas. And that can be really useful because you might get some good ideas, but you're also learning about what do these people think is important to them in a good solution or a good idea. They also spend a lot of time doing these very rough sketches that you see pictured in the slide. And again, the goal is to see if you can come up with 100 different ideas. So they're not fully fleshed out CAD models. They're not even really nice drawings. They're just ideas that are visualized just enough to get the idea across so that you're coming up with a lot of ideas. And then in the end of this phase, they kind of had two main directions. So one direction was about changing the mechanical properties of the toothbrush to make it easier to use. And the second direction was either an app or maybe a robot that would sit on your bathroom counter that would kind of provide guidance and coaching and feedback to kids as they were brushing their teeth. So then they move into the deliver phase. So they say, okay, we have all these ideas. We've narrowed it down to a couple of different directions. How do we deliver solutions that work? They quickly realized that they would make much more progress with a toothbrush than the assistive device, and that a toothbrush would be more helpful. And they started to define, how can we design a toothbrush that behaves differently than other toothbrushes? So they have this pivot brush head that swivels across the teeth and makes the actual movement of brushing your teeth less complex. They took a page from the tennis ball and made a textured handle that's easy to hold, but also easy to clean. And then they had some thoughts about vibration and how they could make vibration in the mouth, but not have it travel down to the handle, which was distracting for some of these kids. Once they have this idea, they spend a lot of time prototyping and iterating. So these are all 3D printed toothbrush handles. They make a bunch. They test them all, they hold them, they put them in kids' hands, we all hold them, and everybody starts to figure out what's the best solution. And I love this picture here because you can see the evolution of, it's basically the same idea, but it gets increasingly refined and increasingly detailed as they move through the process. But it was basically, you know, a pretty set idea at this point. And then they take it out and they test it with people. So in this case, you can see they're at the Penn Dental School, and they're talking to dentists and teachers and students to talk about how would this work and is it an effective toothbrush? Because obviously there are certain trade-offs you can't make. It could be easier to hold, but if it doesn't actually brush kids' teeth, then it's not worth them starting to use. And then finally, they get to a point where they can put the toothbrush in kids' hands and have them trying to brush their teeth. So I'm going to show you this video of this young prototyper who was working with the team. And at the beginning, he starts trying to use a different toothbrush. And then you can see what happens when he starts to use the Swiv toothbrush.
Go ahead.
So one of his challenges with regular toothbrushes is that he bites down on it and it just stays in one place.
Brush them teeth. You gotta move it.
And then this is the Swiv toothbrush.
Slow. Good job.
So that's his first time using it. That's his second time, and he's watching a video that the students made to show him how to use it. And then by the third time using it, he's able to be much more successful with brushing his teeth with the toothbrush. And you can see he does the top and the bottom. And this is the best part. He's so proud of himself.
Good job,
when he's able to brush his teeth. Okay, we don't have to watch it again. So this is the story of the Swiv toothbrush. And what was really compelling to the team, he is adorable. What was really compelling to the team about this is the more people they showed the product to, first of all, anyone who had a child with cognitive disabilities was like, oh my God, this would be incredibly helpful. And then people who had children of different abilities also thought it was a compelling solution. So what they heard over and over again is that this was a solution that every kid in the house could use, and that they could use it together. And which turns out to be, there's a principle called universal design, where you're designing for specific people's needs, but it ends up being useful for a much wider audience. And this seems like something that would help any kid, but be particularly useful for kids with cognitive disabilities. So that's just one of many examples I can share, but I think it does a really nice job of describing how you diverge and converge and redefine the problem, and then how you prototype and iterate and generate a lot of ideas on that second half of the double diamond model. Okay, so any questions here about that toothbrush or the process? Okay, so now I'm actually gonna, I'm gonna share my screen for a second, but then I'm gonna stop sharing my screen. And this is the point where, here, I'm gonna stop sharing for a second, where we get a little interactive. So there's a couple of kind of points I wanna drive home about this process that require some activities, which requires you guys to be a little bit engaged. So if you have a piece of paper nearby and a pen, that would be super helpful. I'm going to ask you to do a little bit of idea generation. And if possible, to draw, but you don't have to draw. But if you can draw, and when I say draw, I mean something like this. Like, it does not have to be a fancy drawing. This is my idea. It's a light bulb. I have some words to help describe it and a little bit of a picture. But we're going to do a little design exercise to make a point. Okay, so the first thing that I'm going to ask you to do is to design a pot. And I'm going to give everybody about a minute to think about what ideas you have for a new kind of pot. And that's the only information I'm sharing beyond that. So I'll give you about a minute. Okay, so some of you have ideas about pots that you might design. Can I ask someone to share their idea? And if you can, just unmute yourself. You can either talk about it or hold up a picture if you have it. Yes, Tiffany.
I thought about, like, since cooking and then you have to touch the pot lid's handle, it might like hurt your hand from burning. So I thought about like some kind of like soft or like material that can like withstand the heat to like, so you can like easily put your hand on it without like burning yourself.
Oh, that's a great idea. So instead of having to have a separate something that you hold on to, just to have that built into the pot. Excellent. Thank you, Tiffany. Who else would like to share?
My idea was that, like, on the handle you would have a tiny display that displayed instructions if you like were cooking something new. So instead of having to look at your phone or like print out a menu, or not a menu, instructions, it would just show up on the actual pot and it would be a lot easier to look at.
Excellent. So something a pot that displays your recipe so that you can look at, just focus on what you're doing and you don't have to look at a cookbook or a phone. Great idea. Can we get one or two more?
I thought of an idea to make like a pot that displays the temperature inside of it. So that way you don't have to use a thermometer and you know automatically like what the temperature is inside. So you can adjust what you need or add more just to be, like correct, I guess. I don't know.
I like that. So it communicates the temperature and it helps you be more precise, but also helps you avoid having to use a separate device to figure out the temperature. Thank you, Suraj. Who else wants to share?
I want to build on Chuck's idea, which is not what I have in my notebook, but if you're putting some sort of display or digital functionality in the handle, a timer, so that when I have multiple pots going on the same time and I have a timer on the microwave and a timer on the stove and a timer on the phone and it beeps and I have no idea what it's for, but if it's attached to the pot, then I'd know which one.
That is a very good idea. Okay, so we're really making these pots work a lot harder for us than they currently do. So we've got a timer, we've the temperature, we have the recipe, it's heat resistance. Anyone else want to share?
I thought of one for like storage. So like I know there's some containers that like the small ones can go inside the big ones, and so it's easier for storage. So I thought like maybe the handle part of the pot, it could be like hollowed out, so you're able to like place each container within one another. But also if you're trying to hold it, so it's not like digging into your skin, there could be like a little like sliding part where it can like slide up so it's like whole again, if that makes sense.
Yeah, so redesigning the handle so that you can stack pots is a really good idea. And then also making sure that it works well in the stacking mode, but also works well while you're still cooking. Okay, great. These are fabulous. Oh, and also Tiffany, materials that change color. So that can maybe display the temperature, also help you understand what you're doing. And also let you know, maybe signal if it's hot. Okay, so that was great. Now I'm going to give you a slightly different design challenge and we'll see what we can come up with. Okay, so now I would like you to think, we're still in the kitchen, but I want you to design a way for people to enjoy cooking in the home. Or ways for people to enjoy cooking in the home. My timer went off. Okay, so I'm already seeing some answers in the chat. Here, let me stop sharing. So Sabrina, can you share your idea with us?
I'm currently at a grocery store because I thought this meeting was at 3. But like I personally, when I'm cooking, like I have some back problems, and so when I stand for a long period of time, I like need to sit down, so it's hard for me to cook and stand the whole time. So there's some kind of chair that like you can adjust so that you can reach the whole stove. That would be nice.
Awesome. Thank you for sharing from the grocery store. Who else wants to share?
I was thinking about how so many people have to cook by themselves right now because they can't be with others. But we like to cook with our kids, and they're remote. So I was thinking, but and then you walk off screen because you have to go get that carrots. So I was thinking of the Zoom chef follower that like somehow you wear the little thing and it follows you around the room. The camera follows you around the room, so you can actually do it with your kids or your parents in some cases.
Okay, and then Tiffany had something that plays music that helps you know when you're doing a good job. Did I get that right, Tiffany?
Yeah, because I was like thinking about like how like kids play with like cooking like toys and then it like plays music. So I thought like why can't the adults have one but like much more catchier. And then I had another idea about like an oven. Like if you forgot about like opening it, like play some kind of song is like this stuff like to say don't forget about me or something.
Rather than that annoying beep that keeps going off. Okay. Oh, and Anthony has an app that gives you trivia and fun facts while you're cooking. And Anthony, that's a really good point, right? You don't want to be too distracted, but you might want to be entertained. So you got to find the right balance there. Anyone else want to share any ideas? Let's see if we can get two more.
I think to build off of Tiffany's point about the music, you could have something play music that's like, if you're cooking Italian food, it could play Italian music. So that way you kind of have more of an in-depth experience rather than just the food music as well.
Okay, so you're like bringing the whole ambiance of the cuisine that you're cooking together with music and food. One more different idea from what we've heard before. Okay, we'll go with what we have. So when I asked you guys to design a pot, first of all, great job on both of those challenges. You guys came up with a lot of really good creative ideas. The pot, we had ideas like a heat resistant handle, displays on the handle, the pot displays the temperature, a timer on the pot, or nesting pots. And then when we thought about ways for people to enjoy cooking in the house, we had a chair to help make it more comfortable, a Zoom chef to follow you while you're cooking with other people, a lot of ideas about incorporating music, and maybe the oven is helping remind you what you're doing. So lots of different ideas. Tell me this, how did the first challenge, design a pot, how were those different from the ideas that we got from the second challenge, design ways to enjoy cooking in the home? Yeah, Sabrina, design a pot was very specific. And the second one was much more open-ended, to Anthony's point. One is you have a set thing that you're designing, and the other one is anything related to cooking. And Tiffany said, yeah, it's more convenience than entertaining. So designing a pot was improving on something, while the second one was designing something new. Any other thoughts? One way that I think about it, sorry, my dog is now showed up, so we'll see how that goes. It's fine, you can leave it. One way that I think about that is designing a pot is really focused on a solution, and designing for people to enjoy cooking in the home is much more focused on a need. So Nyla, yes, you got it right. So when you frame the challenge in terms of the solution, you're already really narrowing down the kinds of ideas that you come up with. We need a new pot. All the ideas are pots. That's what we asked for. But if you frame the solution in terms of a need, you have a much wider variety of types of solutions. So some people might come up with pots, and we had some solutions around ovens, but there was also maybe a Zoom robot, and there was also adding music into the experience. So it's much more open-ended when you start designing for a need. And I think that this difference compares to what you guys are trying to accomplish now with the traditional robotics challenge. So traditionally, you're focused, I'm going to make a robot that does these things. And so you're focused on generating ideas around really specific solutions. But in this innovation challenge, it's much more wide open, and a way to enable yourselves to get more creative and to come up with a wider range of solutions is by framing things in terms of the need. One thing that is helpful in framing it is to remember, if you're talking in terms of nouns, this is where English class meets engineering. Solutions are nouns and needs are verbs. So anytime you're framing your design challenge as a noun, you might be constraining it by a solution, versus framing your challenge in terms of a need, kind of in terms of a verb, opens things up to a lot of different ways of doing things. Now, there's a lot of needs related to cooking, right? I wrote to enjoy cooking, but I could have said to get dinner on the table quickly, right? there's a lot of different needs, and then you can open up the problem even more. But anytime you're framing it in terms of the need, you're going to come up with a much wider range of solutions, and they're likely to be more creative than if you just frame it in terms of the solution. Questions about that? Let me ask you another question. Which one did you think was harder? Coming up with the ideas for the first challenge, design a pot, or coming up with ideas for the second challenge, design ways of enjoying cooking in the home? And you can just put in the chat which one you thought was harder. Okay, this is so interesting. It's a little all over the place, which I think is normal. I find that like when I'm teaching college students, and actually even more when I'm teaching professionals, they have a much harder time on the open-ended idea generation on the second one, because they're very used to focusing on solutions. And it's okay for one to be harder and one to be easier, but it can be helpful to know that like, oh, I have an easier time working on problems that are well-defined, or, oh, I have an easier time working on problems that are open-ended. And the beauty, I think, is from this group is that it seems like many of you had a little bit of a hard time with the second one, but some of you had a harder time with the first one. So I think that the best way to go about these kind of challenges is together and collaboratively, because you might find that you're the kind of person that works better with one kind of problem and somebody else works better with another kind of a problem. And when you're working together, you can really help yourself out. You can also kind of train yourself to get better at coming up with ideas for these open-ended solutions. And so I'm going to show you 2 things that you can do to make things easier. But I guess let's dive into this. The reason that the second one can be harder is many of you are used to solving problems where the answer key looks like this, right? There's a single answer to every problem. In the world that I live in, this is what the answer key looks like. It's much more ambiguous. Maybe it's A, maybe it's B, maybe it's C, maybe it's D, I don't know. There's a lot more ambiguity. And so those kinds of problems can be harder to solve, which is why you want to try to come up with as many ideas as you possibly can, because you're not sure which one is the right one. And in studies about creativity, people look for 2 things to make you that says that you're creative. One is your fluency in idea generation, which says you can come up with a lot of different ideas. And the other one is your flexibility, which talks about how different are your ideas from each other. And the good thing about both of these things is you can train yourself to be more fluent and more flexible with your idea generation. So one tool that I might recommend that you try for this challenge is to structure the way that you come up with your idea generation. So this is a creative matrix. This is about, you can see in the top left-hand corner, the experience is delivering fresh out of the oven pizza. And across the top, you have different needs. So we need to prevent pizza from getting soggy, to deliver the pizza faster, to improve the ordering process, to reduce physical deterioration. And then along the left-hand side, you can list how you're going to deliver that. So is it through green materials, new technology, partnerships, or infrastructure? And then you can see if you can come up with ideas in each of these boxes. And I kind of made one of these based on some of the ideation that you guys have in that document, where across the top, there are these needs, and it's around like managing time when schoolwork is happening, remembering to take breaks, getting physical exercise when everything is done on the computer, setting aside times for different activities. And then you can create types of solutions along the side. Is it an app? Is it a physical product? Does it leverage the Internet of Things? Does it include other people? Is it good for the environment? And you could have a little brainstorming session where you kind of fill out each of these quadrants, and that'll push you to have more ideas and to have a wider variety of ideas. And then the last technique that I'm just going to talk about, but I don't think we're going to do it because I don't think we have time, is called bad idea generation. So anytime here's what happens to me. If I sit down and say, I have to have a good idea right now, guess what happens? I got nothing. my mind blanks. I put so much pressure on myself and I can't come up with a single idea at all. But if I think about like, how can I come up with 4 bad ideas for how to solve this problem? Suddenly I've got a lot. So if I want to think about like, what's a bad idea for enjoying cooking in the home? All the recipes have to involve 100 steps and they have to use ingredients that I've never heard of, right? It's much easier to think about bad things than it is to think about good ideas. And that kind of loosens your brain. And then you can think of like, oh, okay, well, if a bad idea involves 100 steps, maybe a good idea involves 3 steps. And you can kind of flip it over. So that's another technique that you might want to think about using whenever you're stuck trying to come up with ideas. So yeah, that was what I wanted to share with you. I think the biggest takeaway for you guys is this difference between 2 things. One is the difference between needs and solutions, and try to make sure that you're generating ideas around needs and maybe structure different kinds of solutions that you can generate to make that process a little bit easier for you. But the second one goes back to that SWIV case study. And that's just around prototyping and iterating. So even when you think you have the idea, you got to try it out, test it out, get feedback a lot of times in order to get to an answer that's really a good answer.
One of the things that I noticed as we were doing the those 2 sort of ideation exercises was I guess there were 2 things. First, I was not just editing out things that I thought was bad ideas, but also things that I thought were already existing ideas. So like with the pot, I was like, oh, well, it'd be great if the bottom were curved so that your spoon could get to the edge. And then I'm like, all right, you've just invented the wok. Applause, right? No good. And then with the make cooking more enjoyable, because the photo that you gave us had like little kids in it, my mind was going right to how do you make cooking more enjoyable when you have little kids, which wasn't, well, like I had put this restriction on that wasn't actually there. And so those were sort of both things that I was conscious that my mind was doing that I wasn't happy with it.
Well, the first one I think is the hardest one, right? Which is like, we want to judge our ideas before we've even said them out loud. And I think in order to be successfully innovative, you have to be willing to say those ideas out loud, because maybe you think it's a bad idea, but maybe Mr. Campbell can build on that idea and make it better, but he can't build on it if you don't say it out loud, right? So I think we have to like turn off that judgment brain and just let the ideas out there. Even like, am I ideating in the right direction? Like, it doesn't really matter, just go and see where you end up.
My other question was about how to structure a project timeline. Like, this whole thing is due March 4th for us. And usually we would have no trouble filling all of that time with just the, just like designing the solution part, right? With just the second half of your double diamond. But now we have like and I think it's probably like you know, it's not that I feel like you go to the double diamond and we now have 4 times. I feel like there should be like a you know, a quadratic relationship here rather than just doubling it. And how do I fit that in 6 weeks?
Yeah, I mean, it's hard. That SWIV project I told you about was an 8-month project. So they had a lot of time. I mean, I would say we never feel like we have enough time with the project. And what's nice about that loopiness is that you kind of have to force yourself to make this, like, you want to give enough time, especially because you guys don't usually do this. You want to give enough time to think about your ideas. But then once you have your ideas, as long as you treat them like a hypothesis and not like a fixed answer, you can always be improving it along the way. So you kind of need to like make some decisions, move forward, build something, test it, maybe move backward. You know what I mean? Like, you don't want to, one of the principles is like, you don't want to get stuck in analysis paralysis. You're better off making a decision quickly, moving forward and testing it and being forced to move back than taking like 3/4 of the time to make the decision. So I would say for you guys, like if I was structuring this, I would structure the first quarter of the time for the first half of the diamond, and then the rest of it for the rest of it, maybe even less.
Are there other questions floating around that the students have got, or the other mentors?
I was thinking about what can sometimes happen, that you get to the, you've converged on the problem definition, and you actually think you know the problem, and then you move forward, and as you start going into developing your idea and delivering your idea, you find out that you actually didn't clearly enough understand your problem definition. Can you talk a little bit about how do you know when it's time to move forward, and how do you know it's okay to go backwards?
Oh, that's a really hard question. I mean, that happens all the time, right? You think you've defined it and you haven't, and so you have to move backwards. I mean, I'm a big believer in that second part of the process, and I don't know how much time you guys will have for this with the work that you're doing, of just like getting feedback from people outside of your teams on how things are working and whether they're working for people. And I think if you start to find, as soon as you start to find a pattern and this isn't working, you're better off going back. Because what happens is people get too attached to their idea, and then you're like all the way at the end and you're like, oh, this is not a good idea, but it's the idea we have, so we're going to move forward with it. So I would say don't be afraid to go back, but you don't always have to go all the way back. I'm trying to think of an example where like students learned about like something that wasn't working, and then we're able to quickly iterate into something better. I mean, that's the goal, is to say, once you know it's not working, don't go all the way back to the beginning. Just think about, okay, what have we learned? How can we change and move forward at the same time? I can't think of a good example right now. But I think you're always worse off holding on to something that you know in your gut is not great than you are sticking with it. And then the other thing I would say, here's the other little bit of advice I have. This is for all of you students. Students lie to themselves all the time about their ideas. They're like, well, I wouldn't use this, but other people definitely would. If you are not in love with your idea and you wouldn't want to use it, nobody else is going to want to use it either. And that, like, you're not always designing for yourself, but you can kind of tell if you think it's good enough for you. And if it's not good enough for you, it's probably not going to be good enough for anyone else.